EmissionsTrack platform, and there will be a section at the end where you can ask any questions. Just so everyone's aware, we are recording this webinar session, so hopefully that doesn't prohibit anyone staying, but I think it's important you're aware. So without further ado, I'm going to move forward. So NevadaNano came out of what was Nevada State University, and our founders were a part of an R&D lab where they developed sensing technology and basically came up with several very innovative sensing technology. And they then spun out from Nevada State University. And for the first 10 years of NevadaNano's history, so from 2004 to 2014, our only customer was the US Department of Defense, where we developed a number of really interesting sensors, but all based around either cantilever or MOS or MPS based derivative sensors. And I'll talk about that in a bit more detail to give everyone an overview of our technology. And then in 2022, we launched what was a product called MethaneTrack, which is an IoT platform focused on close proximity continuous monitoring. And that platform has evolved into also include EmissionsTrack, which is the basis of the conversation around our hydrogen solution today, and that uses the proprietary MPS platform. The other areas that NevadaNano are focused on, we do a lot of work in the refrigeration space, so safety as well, control systems, and we'll also look at how our sensors can be used for battery off-gassing. But the main part of the presentation is going to be looking at our sensors and how they can be used by different manufacturers and how they can help to integrate and provide a broad solution leveraging our technology. So this shows you really the two obvious packages to prevent any confusion. So on the left shows you the EmissionsTrack, which is a battery powered device but uses our sensors. And then on the right shows you the MPS sensor, series 4 on the left here, where hopefully you can see my mouse. And then on the right shows you the Mini. For those of you who like to see visuals, that shows you the Series 4 package. So that's potted and is intrinsically safe and ATEX Zone 0 or FM Class 1 Div 1. And that's the Mini package. So why is the MPS really relevant to hydrogen? So traditional sensors add a lot of value and have done a very good job for years. But as the hydrogen economy grows, certainly we see a lot more of that in Europe and Asia and is expanding across the Americas. Certain traditional sensors like an infrared cannot detect hydrogen, and Pelistors, which is another alternative traditional sensor, is quite high power and can have problems around saturation or get poisoned. So this means that the MPS, as it detects hydrogen very accurately, it can measure it as an individual combustible gas or in blends of combustibles. The MPS sensor cannot be poisoned or saturate with hydrogen or any gas. And it's also low power compared to other relative sensors. So, some really clear, obvious benefits. The other big area that's important to appreciate is the MPS sensor does not need to be calibrated for in the field or within the life of the sensor. And so some really strong value there in the sensor will last up to 15 plus years. It doesn't need to be calibrated. You can bump test the product from a safety perspective, but there's no need to do effectively a calibration as you would do traditional sensors. Some of the clients we work with today do a form of a bump test to meet local legislation requirements. So that's really the key summary on why that's so important. The other thing that's the critical to any of this element is, as you can see on this bottom right here, we can provide any of you the data and the supporting evidence to anything I say as we go through the webinar offline. And we pride ourselves in having that supporting data so that you guys can look at that at your own leisure and understand how the MPS could be used within your system. So the MPS stands for Molecular Property Spectrometer. It is a MEMS transducer. And I will explain how it works in a little bit more detail. The sensor itself takes advantage of the thermodynamic properties of air and gas. So it has similarities to what you would class as a historical TC sensor, but their sensor responds really well to methane, all hydrocarbons and hydrogen. As I said, it also does a fantastic job around refrigerants, but this webinar is focusing in on around hydrogen. I've already said about the sensor doesn't need calibration. We've got 6+ years of data to support it. Another thing that's critical that gets overlooked a lot of the time is the sensor, or the MPS, will perform really well from -40 up to 75 degrees Celsius and up to 100% humidity. And that's because we do what's known as inbuilt environmental compensation. And that sounds trivial, but when you consider sensors like IR sensors have really big issues to humidity changes, we do that to support our stability and our accuracy across that wide environmental range. And we have clients that have really pushed the technology, and whether that be Canada or effectively the Middle East. So we're very confident on those performing in the harshest of environments. And I've touched upon as well the 15-year life. Over here on the right shows you the sensor in a bit more detail. And as I said, we'll go in and talk about that and explain how that works. So you can see here on the bottom right the actual Mini, and you can see the larger sensor image here shows you the S4. The S4 itself and the Mini have the exact same electronics. There is no difference at all in how they're designed, or actually how they're manufactured from a component and hardware perspective, but how they're manufactured to achieve certification does change. But looking at how the sensor performs itself, so we have here the package of the actual sensing element. So this sensor that's shown here on the top right is pulled across here very, very tightly, and this effectively forms a cavity. And so air will actually, and gas will diffuse through the actual metal. So it shows you again, so you can see the top here of the sensor. So that will diffuse physically through there. You could have a Gore-Tex filter on there or some description to get a high IP rating, which is used in a wide range of portable and fixed devices, but that doesn't really impact the speed or the performance of the sensor at all. So as I said, the actual gas and air will diffuse through this mesh and into this cavity, and then the actual element itself is a very clever hot plate. So we will actually heat that up to a certain temperature, and as I said, it uses the thermodynamic properties of air and gas. And then next to that sensor, we have an environmental sensor. And so we will measure the energy needed to get the hot plate to a certain temperature. And so once we understand that from effectively the resistance of the thermometer, we can very, very accurately start to calculate what is the environmental conditions and how much energy is present. We're also able to understand the sort of gases and the density of the gases we're seeing, which allows us to also be able to provide gas classification, which we'll talk about in more detail. So that's a summary. If at any point offline you want to reach out to me, I will share my contact details, and I'm happy to talk or arrange one of our engineers to talk about the sensor in far, far more detail. So as I said, as a final summary on how the sensor works, we take advantage of the thermodynamic properties of air and gas. We measure the energy in the actual element to actually get the sensing element here up to a certain temperature. And with that level of detail, we will use the environmental compensation data we have in this sensing element, and we run the mathematics on it to allow us to get there. But as I said, that's a summary. If someone wants more detail offline, please don't hesitate to reach out. So looking at the sensors themselves, we offer our sensors in effectively a 3 or a 5-pin version of this. And so that you can take an analog variant, so very similar to a traditional Pellister sensor, or you can take a 5-pin, which as you can see here, a digital output. So I'm not going to go through every single line item because I've talked about it, but effectively, as I said, no calibration. We do the environmental compensation for temperature, pressure, and humidity. The sensor can't be poisoned. True LEL, I will explain what that means. So where you have normally a sensor that is calibrated to one gas, the MPS has quite uniquely able to detect up to 14 gases extremely accurately. And so a traditional sensor is calibrated to a gas, whether that be methane or propane, but the MPS is calibrated to methane in the factory. But because we understand the density of the different gases, we can then do forms of compensation or use a K factor internally to provide extremely high accurate measurements, i.e. plus or minus 10% across the whole temperature range, which is why we use that term true LEL on our flammable devices. I've touched upon the 15 years life and that we offer an analog and digital output. And I'll come on and talk about that in a bit more detail, because if you're looking for an analog sensor, we will give you a specific voltage range of say 0.4 to 2 volts, but there is also the ability to change that scale to meet your needs so your circuits don't have to change. The digital UART is a standard industrial UART communication, and we can share, the serial comms and the detail on how to implement that. Gas classification, I'll show you some good examples there and explain how that can be valuable. And it's certainly something that you see some of our clients use to actually articulate what sort of gases have been present at a site or during a confined space entry, for example. And because of the wide environmental range and that compensation work we do, that really reduces the sort of false positives that you might see compared to other sensors. And ultimately, the actual sensor's T90 is very fast. So if you're looking at a T90 for just one gas, that's about 20 seconds, where if you're looking at a T90 for a number of combustibles, that will still be below 30 seconds when you're looking at a true LEL value. So a high performing, fast responding sensor. And I've touched upon that it's got very low maintenance in that you don't need to calibrate it, and it has got global approvals in that it's got ATEX Zone 0, it's FF, FM, Class 1, Div 1. We have variants that are compliant to the latest version of the IEC 679-29-1, so the 2022 version, and CSA 22.2. So really, and also IECEX, so a really wide range of different global approvals. And we optimistically believe we will have EN 5271 in the next 4 to 6 weeks. So a really good global approvals, so you can use it in many applications. As I said, we offer 3-pin and 5-pin versions. If you have a 3-pin, it's like a traditional analog sensor, and so it's very much, we have a fault signal and we have a analog output. And if you have a 5-pin version, you obviously get far more information, whether it be diagnostic, gas ID, etc. And we'll talk about that. So hopefully that makes sense. So I talked about the analog signal that you might see from a traditional sensor like a Pellister. One of the things that the MPS can do is we can configure that signal. So traditional signal is from 0.4 to 2 volts. If you need to adjust that up or down, or have a small range that you might have a 0 volts at say 1.8 coming down to 1.5, like some traditional sensors, we can do that as well. So if you're looking for a drop-in replacement sensor that can see hydrogen and you don't want to change your circuits, please talk to us. And we can share far more information on how we can configure that sensor, and ultimately you can put it in a digital sensor with a configured analog output to meet your circuit needs. And we've got a lot of experience in that area, and certainly, as I said, when you look at hydrogen and having something that you might only have a Pellister, so you could reduce power with the MPS, or if you're using IR, it gives you access to measuring hydrogen as well. So please don't be shy if you want us to look at configuring that for you. From a digital output perspective, as I said, here on the left shows you that we can give you the gas reading. So the traditional gas, what is the LEL value? Or if you're using one of our ppm sensors, what is the ppm values? We will provide gas classification. So what does that mean? We have 6 different classifications of gas, and every time the sensor samples, we will provide a gas reading. And so we cannot tell you that there's 5% LEL of hydrogen and 10% of pentane. We cannot do that. What we can do is, if we see hydrogen, we will give you the LEL value of hydrogen. And for example, if you've got hydrogen and methane, it will show as class 2, and we will give you that value. If there's only hydrogen, it will show as class 1. And this is a really important piece, that if you use a digital sensor, you can make it where it effectively filters out other combustibles. Many people might use the chem equivalent, and that has many side effects with cross interference of other gases. So this is one way, using gas classification, to guarantee the sensor will not react to other gases. So this is a really important thing. And if you start to look at gas transmission, where you were looking for hydrogen in traditional areas, you can also start to look at, am I seeing hydrogen and effectively natural gas in the classes 1 to 3? And then if you're looking at other gases that might be present, such as propane and ethane, with a generic flammable, you can still actually start to see that with the different gases that's there. So really quite a data-rich sensor. And if you consider on top, you're going to get the temperature, pressure, and humidity, providing far more granular information than you get from effectively traditional sensors. And finally, you get information regarding the sensor's condition. So if it's in a condensing state, if it's in a high temperature or high humidity, you get all of that. So some real benefit. So if you're looking for just an analog signal, we can configure that as a drop-in. If you're looking for a digital solution, again, really provides some quite unique features. Okay. So some of the areas and applications that we've seen in the industry develop over the last few years, obviously battery off gassing, and that's something that I'll talk about, where people have been looking historically for just hydrogen. And if you think about how a battery will fail, hydrogen from a PF curve perspective is really down at nearly thermal runaway. So that doesn't really add much value. So that's an application we see a lot of interest in. We also do quite a lot of work around capacitor off gassing, so polycarbonate capacitors that might break down. They predominantly see nonane and decane, but it is an area that we can help in. I touched upon on the previous slide regarding gas transmission and distribution. And so if you were looking at just hydrogen with class 1 or hydrogen and natural gas, you'll see that in class 2. So that is really an area where we've seen a lot of interest. And then if you think about applications where you might see fire brigades or first responders, if they arrive on site with a portable device, they might calibrate to methane, and they really don't know what sort of gases that they will see on site when they arrive. And so the MPS provides a sensor that will react to all hydrocarbons, but obviously also hydrogen, where a lot of devices people have been using are IR based, and as I said, won't detect it. We can also see heavy hydrocarbons that sometimes get filtered out on pelleters as well. So really a real improvement on safety, that if you turn up on site there, if you're going to potentially see hydrogen but a wide range of different combustibles, the MPS offers you a more rounded and safer sensor, especially when you think about the true LEL element. Other areas where we see the need for hydrogen, power industry, obviously our sensors can't poison or saturate, and in the nuclear industry there's a big need for sensors that can detect hydrogen, and pelleters can saturate in that environment. Hydrogen generation, so we're all aware of the growth of electrolyzers, and we've done quite a lot of work in that space where the oxygen level will change and vary. and we have experience in helping to provide the most accurate hydrogen region we can, even when that oxygen levels will change. General hydrogen leaks, obviously we can do that in sort of a simple diffuse mode, and we'll talk about our EmissionsTrack platform in more detail on where we can provide quantification of those sort of leaks. So that's really some of the applications that might be relevant to you. And as I said about batteries, hydrogen is becoming important from an off-gassing perspective. It doesn't provide, though, the earliest warning, as I said. And so if you look here, I'm showing the PF curve on this bottom right image. And so you've got functional failure down to potential failure and how that deviates from a normal operating condition. And so what I'm actually suggesting is hydrogen is down here. But if you start to think about how can I actually do something about it, you can start to detect DMC, because people think, oh, I've got hydrogen and I've detected it from sort of a water element. But really, if it's not water and it's actually battery breakdown, you've got a much bigger issue. So really, hydrogen is not the best gas to detect with breakdown. And really, you want to start looking for DMC and EMC as that goes away. And then obviously you want to start thinking about the temperature increases. And so as you see the different gases build and then also temperature increase, that really allows you to have a far better awareness of that battery's condition. And I think that if you detect that sort of potential failure here, you can do something about it. If you're waiting for hydrogen, that is just simply too late. And that was when the sensor will get into thermal runaway. So that's really an important area. And if you think, how would I implement that? If you've got a digital interface and you're looking at our sensors, so again, as I said, class 1 and class 2 will give you hydrogen across that whole spectrum. But we know from internal and external independent testing that the actual MPS will really react very consistently to DMC and EMC. You'll normally see DMC in class 5 first, and then as the build up of EMC as well, it will transition into the class 6. But from a logic perspective, if you're looking for these types of gases, it's a really good way to get you that early warning before a failure occurs in the batteries. And so, as I said, it's about detecting it here so you can do something about it, as opposed to waiting for the functional failure. But as I said, you can do that very easily with the gas classification within the MPS. So moving on to look at our EmissionsTrack platform. So we took our proprietary MPS sensor and built it into this device you can see here, which effectively we've added batteries to and also a LoRa-based radio module. And so there are several different sorts of continuous monitoring systems that are available on the market today. But they're all really focused around fence line, and the fences don't leak. And so we've been using the term close proximity continuous monitoring because our devices are ATEX Zone 0 or FM Class 1 Div 1. So although I appreciate this is not a hydrogen application image, it's a good example of how physically close we can get to a source like a thief hatch. And so because it's battery powered, very quick to install, really non-intrusive. And then the system itself will be able to quantify and can provide quantification, and it can speciate effectively the different levels of hydrogen v hydrocarbons. And because it hasn't got any need to be calibrated for that long period of time of the sensor's life, it has a low cost of ownership. So looking at it in a bit more detail, as I touched upon, there's a wide range of technologies that are available and some really great laser-based solutions. But these sensors could be over at the fence line. So if you look at this image here with an EmissionsTrack endpoint on a tree, as opposed to being over at the fence line 50 to 100 meters away, consider that if you're physically close to the emission source, you will get a much higher concentration, which in fact will give you lower false positives, and more importantly, faster and more accurate location and improved quantification. So our system is very much provides a simple and clear, consistent measurement. And as I said, the fences don't leak, and so that sort of fast, reliable measurement, and obviously because it's very much a fix it and forget it approach to those sort of endpoints, it really provides accurate readings from a close proximity perspective. When you talk about hydrogen, I mean, there's a number of projects and certain clients that we're working with. I can talk about this project with National Gas because it's public domain, and you can scan this QR code to provide more information about what we're doing with National Gas. But we've been lucky enough to work with them on their future grid facility in the UK, where they've been testing effectively natural gas and blends of hydrogen. And our EmissionsTrack platform has been there helping them detect leaks and help provide quantification for different leak sources. And so we're lucky enough to be working with them at Future Grid and one of their operational sites. And this project has allowed NevadaNano certainly to have a much better understanding of how our system performs with hydrogen and natural gas in a gas transmission perspective, and also has helped National Gas understand how that they can understand how hydrogen leaks work, because hydrogen is much smaller molecule, and how leaks occur at different pressures is a real critical measurement for them to understand and to actually have more data on, so they can prepare their maintenance appropriately. So as I said, feel free to scan that QR code. It talks about some of the project, and I'd be very happy to talk about that offline, and you can find a lot of information about Future Grid in the public domain. So I've touched upon quantification, and I think it would be remiss of me not to highlight the addition of the leak source isolation, and ultimately this image in the top right shows you a potential configuration. So this is an upstream site, but you could have our system configured with a LoRa radio, so you'll have a gateway at a specific point, and so where we can connect to your internet, or we can have a cellular backhaul. Ultimately, you'd have the endpoints around the site, whether it's on tanks or pump jack or a separator. And when a leak occurs, we have the ability to actually understand where that is. And very simply, we basically will get into the data and use the different endpoints and wind speed to understand also wind direction data to calculate and the actual triangulate where the leak is and where that data is. And so there's some great case studies we can look at, predominantly in the oil and gas space, that shows you evidence that if you have a leak on a part of your plant, different endpoints will build up that confidence level as we see those values increase, and that allows us to have a high confidence when we provide a leak source location, as it's shown there in red. The bottom image here on the right shows you some of the information the system will give you. So you can have the leak rate, and you might want that in kilograms an hour. That's available. The volume, when the leak starts, when it ends, and the duration of those leaks. And that provides a really clear, granular level of detail that any operator would be able to actually do something with. And from that, they can make a decision on would they want to send someone to site, or will they do that immediately, or is that an element they need to do with general maintenance when someone's next on site. But if it's significant, and some of the fines that we're seeing in industry at the moment, it's certainly an area that helps you make supports decision support and aids in helping operators reduce emissions in unneeded places. So that's some of the benefits from our LSI. And when we talk about that close proximity, it really gives significant value, because we're close to the leak, and it gives us very high confidence. So as a summary, talking about the MPS sensor first, I mean, it is very much a digital sensor that we can provide, lots of data on, whether that be temperature, pressure, humidity, the gas ID, which you can then use to provide logic around, so you can actually understand what sorts of gases are present, and if it is hydrogen or battery off gassing, you can push that information into a relevant controller. We can also provide configured analog outputs. So if you've got a circuit that you've been able to use for other sensors and traditional technology, let us know. We have experience in configuring the analog output to mirror other types of gas sensors, and that may allow you to drop in the MPS with no need to change your board, no extra certification. And as I said, it's an area we've got a lot of experience in. The sensors don't need field calibration. Obviously bump testing is a safety element and might be needed from a legislative perspective, but as I said, you don't need to calibrate the sensor for the life of it, and it cannot be poisoned or saturated. So where other sensors can fail and there's no feedback that the sensor has actually poisoned, the MPS will provide that detail, whether it's an analog signal of a failure or a status flag. So provided far more level of information on the sensor's current state and condition. When you look at the MPS's power consumption compared to traditional sensors, it is very low power compared to a Pellister, somewhere in the factor of 10 less power consumption. I know there's some really low IR sensors out there. However, they can't see hydrogen, and this is the aim of that conversation. We've talked about obviously blended combustibles and how the MPS really performs very well with blended combustibles, and that's where we use the term true LEL. And obviously the MPS will see hydrogen, within, I think it's plus or minus 5% for hydrogen, so extremely accurately across the whole environmental range. And as I said, we've talked about the gas classification. So that's a summary on the alternative, types of sensor compared to traditional for the MPS. And obviously we've took that proprietary technology and put that into the EmissionsTrack platform. And as I said, that is a cost-effective close proximity device because it is intrinsically safe. So ATEX Zone 0, you can put it anywhere on site. And because it's battery powered, it can be installed very, very quickly. We're regularly doing installs, and it's not a lengthy process. It's something that we've got experience doing quite quickly in a efficient and structured manner. The actual EmissionsTrack platform talked about that it's actually maintenance free. We do have options that will give you up to 5 years battery life. And we are doing pilots on a platform called Betas at the moment, and we'd love to talk to you about how that can be used or how you could use that system. But because of the MPS's wide environmental range, we're also finding out that it's very reliable, whether you're looking at applications in Scandinavia all the way through to the Middle East, and up to high humidity doesn't impact the sensor. So truly a global solution. I've not really got into it in this webinar, but we would be happy to have a more detailed discussion around potential data architectures. And so currently we host the system, but have flexibility on how we can share and push data into different clients' infrastructure. But the value from that data we push is driven by our advanced algorithms, such as quantification or effectively the leak source. So it really provides a lot more information at your site level. And when you look at the legislation that's coming in Europe, so the Fit for 55 on reductions, and that's now going to be required for anyone importing into Europe and all European operators. And obviously some of the things that we're seeing with the EPA Quad B, there's certainly a real drive from a legislation. And if you're not aware of OGMP, there's now 130 plus of the largest oil companies, coming together and looking at that as a global solution. So I'm hoping that summary was helpful. These are my contact details here. but I do welcome, any questions that anyone who's attending may have. Jeff, I don't know if you can share any questions. Jeff, do you want to share any questions that I have? I can't see any.
There have been no questions. If you have some, put them in the chat or just unmute your mic.
Hey, Gary, this is Xavier with Emerson Rosemount.
Hello.
My question to you is, how do you compare the MPS technology with infrared? Because infrared is, typically T90 response is like 2 to 3 seconds compared to MPS, where you're looking at T90 at 30 seconds, which is getting to like, I don't know, it's getting too far maybe or too late.
So I'm not so from someone who's been involved in infrared sensors and used to design them. I'm not aware of many infrared sensors that are 2 or 3 seconds T90s. I see a lot of T50s around about 10 to 15 seconds on certain gases.
Yeah.
At T30, T50, sorry, with methane is sub 20 seconds. And effectively, if you look at blends of combustibles, as I said, you're going to still be well below 30. We find that we're very comparable in performance in the field. And obviously, when we talk about hydrogen, regardless of how fast that response time is on an IR sensor, it can't see hydrogen.
I agree
and
with
then,
you.
and
Yeah.
so I mean, I would say we do the MPS platform, and we've not really had much negative feedback in the market about T90, because some of our refrigerant sensors using the same hardware are sub 6 seconds for T90. So our R32 sensor has got a very fast response time, where because we've got such a wide environmental range, our real focus is not giving false positives. If you think about, if you come in from a steel plant in Poland and you come from the outside and it's -10, and you go into the hot strip mill and it's, there's ambience of 40 plus, we're really focused on providing no false positives. So that's why we've tuned the sensor that way. But are happy to take an action to give you more detail on T90s if you'd like to see that.
Yeah, and I had another follow-up question as well.
Yeah, no problem.
That's regarding when you like package it in a transmitter kind of design, you would need to use like a flame arrestor or something in front of the sensor. That's what has been done with catalytic bead. Do you think that would infringe upon the higher molecules entering the sensor itself? Because you need to meet area classification, right?
Yeah, so we don't have to put a flame arrestor on there. So this shows you sort of one of our typical sort of fixed endpoints, and ultimately what we use is we use just like a Gore-Tex filter, and there's not enough, the actual sensing element. There's no power in there, so there's no risk from combustion. So we don't have to put a flame arrestor on there. So ultimately, we will see in our methane emissions or our generic emissions piece, we'll see C1 to C12 and hydrogen, and then we can process other data in the cloud. So there's no impact of that at all.
Okay, perfect. Thanks.
But good question. Thank you. Any other questions or comments? I can't see anything in the chat specifically. Any other questions from anyone?
Yes, I have a question. Hi, Gary. I'm Marco from Italy.
Hey, Marco.
In application that concerns safety, the sensor has parameters as reliability or seal level in order to be used application?
Yeah, so we have many independent test reports, and we're hoping to get EN 5271 approval literally next month. That's been a very long piece of work for us as a business. It's been a significant lift. But yeah, we've got accelerated life testing reports. We've got just under 7 years of test data that we can share. And as I said, we've got accelerated life testing for the sensor internally and external independent reports. So, I would say that we've now got, well over 1 million sensors in the field in the harshest of applications. So we're pretty confident on the sensor's performance and reliability. So hopefully that helps, Marco. But if you'd like us to share any data offline, please don't hesitate to scan that QR code or send me an email, and I'd be happy to send and follow up and give you that information.
Okay, thank you.
Pleasure. Any further questions? Okay, so thank you very, very much for everyone's time. As I said, I will follow up, and if anyone's got any questions offline that you'd like to reach out to me or some of the team at NevadaNano, we'd be very happy to arrange an alternative or a separate call to talk in more detail. So once again, thank you so much for listening, and yeah, please don't hesitate to talk to us in the future, and yeah, thanks again for your time. Thank you. Take care. Have a great weekend, and all the best.